Greetings, science students. Welcome to Gnostic Academy. In this video, we are going to revise chemistry or science paper 2 of 2024 GCE. All right. So we have to answer all the questions, section B. Okay, all the questions in section B was it's just 45 marks. So let's begin with the first one. A box of chemicals in a laboratory has the following symbol attached to it. Okay, this is the symbol attached to a bottle of chemicals. Now, describe the nature of chemicals in the box related to the symbol. Okay, so whenever you see this symbol, just know that it means that those chemicals can easily catch fire. Or catch fire easily. Okay, so you say describe the chemicals in the box. The chemicals, okay, you say chemicals easily catch fire. Okay, sometimes they can be written highly flammable. Highly flammable. It's just one and the same thing, easily catching fire. Okay. Now, write a laboratory rule which that is observed when handling chemicals in this box. Okay. So, if it catches fire, then automatically it needs to be, so it must be kept, okay, in a cool and dry place. Okay, in a cool, all right, and dry place. Okay, cool and dry place. So when you say cool and dry place, it means with low temperature. Okay, with low temperature. All right, let's proceed. When a bottle of ammonia is opened, within a few minutes, its smell spreads throughout the laboratory. Name the process responsible for the evenly spreading of the smell of ammonia solution. So the process here is called diffusion. Not osmosis or active transport, but it is what? Diffusion. Okay? Diffusion. Because diffusion is just the movement of particles from the region of higher concentration to the region of lower concentration. Okay? Lower concentration, down the concentration concentration gradient. Now, describe the process responsible for the even spreading of the smell of ammonia solution. Describe the process responsible. So we have to describe what? Diffusion. Okay, so diffusion of ammonia particles move from particles, diffusion of ammonia. Okay, during diffusion, let me just say, during diffusion of ammonia, particles move from the region of high concentration. Okay, high concentration to the region of lower concentration. Okay, the region of lower concentration. Let's just end here. This is just a mark. Let's proceed. Relate the evidence which the process named in question A, Roman numeral 1, provided to the kinetic provides to the kinetic theory of matter. Now we need to know what the kinetic theory of matter states. So the kinetic theory of matter states that matter is made up of tiny particles that are in continuous random motion. So here you can just say particles of matter are in continuously, okay, continuous random motion. Okay, then continuous random motion. So we're done with question. This is question what? Question 1. Let's go to question what? Question 2. Okay. So question 2 here, we are given an apparatus. They're saying the following diagram shows a piece of apparatus used in the laboratory. All right, so this is the apparatus here with the stopper and the tap here. The first question is, name the piece of apparatus shown in the diagram. So this apparatus here is what? Is a separating funnel. Okay, separating funnel. A separating funnel is an apparatus or a separation technique or method that is used to separate two immiscible liquids. Liquids that do not mix completely, like oil and water. Okay, so question B1, identify one property of a mixture separated by the piece of apparatus named in 1. Yes, you can say immiscible liquids. Okay, immiscible. Okay, immiscible liquids. Okay, immiscible liquids that do not mix completely, that do not just mix. Okay, now suggest the names of two liquids that can be separated by the piece of apparatus shown in the diagram. So you can say water and oil. Water and oil. Last question, on question 2, suggest two precautions that need to be taken to separate the mixture in B2. Okay, now two precautions are that, number 1, this tap needs to be closed, okay, before filling the funnel. So close the tap before filling the funnel with a mixture. Okay, then number 2, suggest the second one is that you need to clean. This must be clean, okay? Clean the apparatus. Okay, apparatus. Clean the what? The apparatus. Which is the separating what? Separating funnel. Okay, which is the separating funnel. All right. So that's all. So we're given 2 questions, but it's a mark. Oh, okay. Maybe there was a mistake. Let's go to question 3. Question 3. So question 3 is saying, the following diagram shows the electronic configuration of the ion of an element M. So this is an ion of element M. Then the first question. Now before we go to the question, look at this. When you look at this, this is the ion, and since it's 2 plus, it means that it is giving out, it is donating. Okay, so there's a transfer of electrons, 2 electrons. So how we can know that this atom is this element is by counting the number of electrons. So you have 2 plus 8, 10, plus another 8, 18, plus the 2 electrons, 20. Then we go to the periodic table, and check element number 20. We're going to find that it is calcium. Okay, it is calcium. All right. So based on that knowledge, we can proceed and look at the questions. Draw the atomic structure and write the electronic configuration of the neutral atom. You see, neutral what? Neutral atom. Yeah, okay. So they're asking us to come up with a neutral atom. So the neutral atom, it is the element before the transfer of electrons, or before getting electrons, okay, or accepting electrons, or before involving in chemical bonding. Okay, so we're going to say, so this is the space that we're given, we draw here. So we're going to say this is the nucleus. Let's represent the nucleus with this one. Okay, the first shell will occupy how many electrons? 2 electrons. Okay, the second shell will occupy 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the third shell will occupy 1, 2, 8 electrons as well. 6, 7, 8. Okay, now because of these 2 electrons that were lost, we have another shell. Okay, like this. So 1, 2. Okay, so that's it. Now you should know that this one is a cation. Cation have fewer number of electrons. You should take note of that. Fewer number, this one is an atom, but this one is a cation. That's what I wanted to say. Okay, so a cation has a fewer number of of electrons than the element. Check. If you count the number of electrons here, the number of electrons will be 18. But here the number of electrons in the atom is 20. So that is a cation. Then an ion, since it's gaining, you don't have an ion, but I'm just explaining. An ion is gaining electrons. It will have more number of electrons than the original atom, okay, than the neutral atom, because it is gaining electrons. So you should have knowledge of chemical bonding. Let's proceed. So the electronic configuration, the first shell occupies up to 2, so it will be 2, second shell 8, then another 8, then 2. So what do we know about this? The number of shells determines the period of an element on the periodic table. So since it has 1, 2, 3, 4, 4 shells, then it is in period 4. Then the number of electrons in the outermost shell determines the group in which the element is on the periodic table. So this element here, okay, let's proceed. Give the name, group, and period of element M. The name here is calcium. Calcium. So you check on the periodic table, element number 20. Okay, it is calcium. Group, it is in group 2. Okay, in group 2. So usually use Roman numerals for groups. Okay. Period, it is in period what? 1, 2, 3, 4. It is in period 4. Okay, it is this simple. Now, compare the reactivity of an atom M and an ion M. The reactivity. You should know that atom of M, so let's just say an atom of M, is reactive. Okay, is reactive whereas the ion of M is unreactive because it is stable. It is now stable. This is reacting because it is what? It is not stable. But this one is stable because that's why it is not what? It is not reacting. Okay, let's go to question 4. So question 4, salts are substances that have many methods of preparation. So you have iron to chloride. Iron to chloride can be prepared by reacting substance X and dilute hydrochloric acid. Okay. Now, which reactant should be in excess? Okay. Which reactant should be in what? In excess. So the reactant that should be in excess is this substance here. This metal. I don't know if it's metal or what. This substance. So we can just say substance X should be in excess. Okay. Oh, we are even asked to give a reason. Okay. Why should the named reactant in A1 above or in A1 be in excess? Okay, so this one should be in excess in order, okay, or to ensure that this acid, hydrochloric acid, to ensure the acid is used completely, okay, during the reaction, okay, during the reaction. Then other questions, question B1, suggest a suitable reactant as substance X. Okay, suggest a suitable reactant as what? Substance X. So now look at this. You need to be very careful here. So since this one is a product, Okay, this one is a salt that can be prepared by reacting substance X and hydrochloric acid. So you can you can see here that there is a hydrochloric acid. So whatever the substance X is, there has to be a metal. Okay, there has to be a metal. Let me show you here. Substance X must be one of the constituents of this metal, this this salt. So since the hydrochloric acid here there is chloride, then ion should be substance X, or substance X should be ion metal. Check. Hydrochloric acid reacting with the ion, this ion, okay? So one of the chemical properties of acids is that they react with some reactive metals to produce a salt and hydrogen gas. So the chlorine and the ion here will be ion to chloride. Yeah, because here we are told that ion has a valence of what? 2, so we can just say ion to chloride and hydrogen what? Hydrogen gas. I'm just explaining anyway. Check. This is ion to chloride. Ion to chloride. Then this is hydrogen what? Hydrogen gas. Hydrochloric acid. Ion. So the answer here is ion metal. So you can just say here ion metal. Very good. Let's go to the next substance. Write a balanced chemical equation for the reaction between substance X suggested in B1 or here with dilute hydrochloric acid. Nice. We've already written this, answered this question here. Okay, let's just copy it this side and balance the equation. Okay, so we can say substance X, since we've said this ion, so we can just say substance X reacting with hydrochloric acid to form ion to chloride. So since ion has a valence of 2, chlorine is in group 7 has a valence of 1, electron of valence of 1, so the 2 will come here, and hydrogen what? Gas. Okay, this one is a solid, it's a metal, since it's a metal solid. This is aqueous, this is a salt, aqueous. Let's check before we say it's a salt. Salts are substances that are many. Yes. Then this one is a gas. Let's balance the equation. So balancing the equation, ion 1, the number of ion atoms of ion on the reactant side here is 1. On the product side is also 1. Now when you look at the number of hydrogen atoms here is 1. Here the number of hydrogen atoms is 2. So what you do, since when balancing, use a pencil because the coefficients tend to change. Okay, so let's put a 2 there. The number of chlorine atoms is 2 because of this 2 which is in front. So also here 2. So this equation is what? Balanced. Thank you so much. Let's go to the next question, which is question question 5, B5. Okay. Now, B5, if you are still together up to this question B5, consider subscribing and liking the video if you are not part of the Gnostic Academy family. So this question is under, what question is this? And more concept. Okay, so 10.5 grams of sodium hydroxide was reacted with dilute hydrochloric acid according to the equation. So this is the equation here. Wow. So the first question is balance the given equation. Well, this is simple. So we're going to say sodium hydroxide, since it's in aqueous here, reacting with sulfuric acid, H2SO4, aqueous as well. to form sodium sulfate, okay, aqueous, and water, H2O liquid. Then balancing this equation, okay, balancing this equation is very simple. We're going to say how many number of atoms of sodium do we have on the reactant side? This side is 1, this side 2. So we're going to change this one to a 2. Okay, like this, we put a 2. Then we go to the next. How many? So we go to the next element, which is oxygen. How many atoms of oxygen do we have on the reactant side? We have, this is 2 plus 4. So we have 6 on the reactant side. How about on the product side? We have 4 plus 1, 5. So we can put a 2 here where there is water here in front, so that it becomes 6 as well. Okay? Take note that the number of hydrogen atoms will be affected, but no problem. Let's just proceed. The number of atoms of sulfur here is 1, here is also 1. So hydrogen has been affected. Only hydrogen has been what? Affected. So what we can do, what we do here is check. Since here there are 4 atoms of the number of hydrogen have been affected. No. So it has balanced. No, it has balanced. So hydrogen 2 plus 2, 4. Here 2 plus 2, 4. So everything now is balanced. Let's go to the next what? Next question. Okay. Next question. B1. Use the balanced chemical equation to calculate the mass of sodium to calculate the mass of sodium sulfate formed. Wow. Now, the balanced chemical equation, so let's get the 2 compounds that are involved. So we are given 10.5 grams of sodium hydroxide. So we're going to use 2 moles of sodium hydroxide. Okay, 2. What else? We are asked to calculate the mass of sodium sulfate. Sodium, so it will be sodium sulfate. Okay, like this. Now, we have to be very careful here. We're going to say, first we need to know the number of the relative molecular mass. Okay, the relative molecular mass of sodium hydroxide and the sodium sulfate. So when you look at relative molecular mass of sodium hydroxide, since we have a 2 here, it's going to be hydrogen. How many atoms of hydrogen? Because of this 2, you have 2. All right, 2 times the mass number, which is 1. Then we go to oxygen. Oxygen, we have also 2. The mass number is 16. Sodium is also 2 times 23. So when you add this side, we're going to have a 2. When we multiply, I mean 2 times 16, 32. 2 times 23 is 46. And then we add. When we add here, we're going to have, this is 2 plus 32 plus 48. This is giving me 80. Okay, 80. So here we're going to use 80. Okay, 80. How about for sodium sulfate? Okay, let's do as well for sodium what? Let's calculate for sodium sulfate as well. So since we have 1 here, so we'll only consider the number of atoms that are here. So 4 times 16, then sulfur is 1 times, is it 32? Let me check on the periodic table so that you don't make mistake. Okay, the sulfur, yes, it is 32. Sodium, this is 2, so it will be 2 times 23. Okay, so when we multiply here and add, we are going to have 142. Since because of space here, we're going to have 142. Okay, so 16 times 4 is 64. This is 32. This is 46. When you add, you're going to have 142. So we're going to use 142 here. 142. Then listen and listen very carefully. Here, you ask yourself, what mass of sodium hydroxide are we given here? They're given 10.5 grams. Okay? Then what mass of sodium sulfate we don't know is the one we want to what? We are calculating. Then we cross multiply. When we cross multiply this times this, it will be 80x. Okay? It will be what? 80x is equals to 10.5 grams multiplied by 142. Then we divide by 80, even this side by what? By 80. The 8 and the 80 will cancel. And then you have x is equals to, so when you punch these on the calculator, we're going to have 18.64. Correct to 2 decimal places, 6.4 grams. Okay, this is the mass of sodium sulfate. Okay, sodium sulfate. Okay, so that's it to this question. So I was explaining, that's why I've taken time here explaining how we get the 80 and the 142, how to get the relative atomic mass, molecular mass, I mean, or formula mass. Then the question Roman number 2, B2, what type of reaction is involved in the equation? This is a base and this is an acid. So this is neutralization reaction. Okay, so it is neutralization reaction. Neutralization reaction. Okay, that's what question B5. Let's go to B6. B6, this is under periodic table. This is under periodic table. So the question reads, an element A is in group 1 of the periodic table. Okay. Another element N is in group 7. Nice. Write one property of the compound formed when element A and N react. Now, you need to know first the type of compound that is formed, the name of the compound. Oh, yes, the type of compound, I mean. So elements A are metals and element N are non-metals. So when metals and non-metals are involved in a chemical bonding, the bonding is called ionic bonding or electrovalent bonding. Now, the compound formed has a lot of properties. Okay, properties. Number 1, you can say it is made up of positively and negatively charged ions, or negatively and positively charged ions. You can say the compound formed in conducting electricity in molten state or aqueous state. It has high boiling and melting point. Okay, high boiling and so there are a lot. So we can just write 1. So let's just say the compound the compound has high boiling and melting points. Okay, there are a lot. Okay, you need to know a number of properties of ionic compounds. What type of bonding exists in the compound formed when the two elements react? Chemistry is very simple, guys. As long as you understand the topic, or understand the lesson, okay, you understand everything, go through different past papers, and the chemistry will be nice. So you see, as I was explaining here, I've even answered this question. So the type of bonding is ionic bonding. Bonding, ionic bonding. You can say electro or electrovalent what bonding. Let's just write ionic bonding. Since you know this is group 1 elements are metals and group 7 elements are non-metals. How does the reactivity of elements in group 1 differ from elements of group from that of elements in group what? In group 7. You should know that group 1 elements, okay, group 1 elements, their reactivity increases as you go down the group. The trend in reactivity of group 1 elements increases as you go down the group. So group 1 elements, I would have said it, okay, it's okay. Group 1 elements, their reactivity increases, okay, increases down the group, increases down the group, okay, whereas group 7 increases up the group. So meaning the most reactive element in group 1 is the element which is down in period in group 1, which is francium. Then the element which is most reactive in group 7, it is fluorine. Okay, fluorine. Are we done with this question? Yes, just 4 marks. Let's go to question. What question is this? Question 7. Question 7. Now, question 7 reads, metallic bonding accounts for most of physical properties of metals. Wow. With reference to metallic bonding, okay, with reference to metallic bonding, explain why most metals have high melting what? Have high melting points, I mean. Okay. So, you can say metals, okay, they have high melting points, okay, they have high melting points because of the strong electrostatic forces electrostatic force of attraction okay, electrostatic forces of attraction between the negatively, what is this, between the negatively and the positively ions, okay, charged ions. All right, charged ions. So the number 2, which is B, draw the diagram to show metallic bonding of zinc. Oh, this is okay. So metallic bonding of zinc. So metallic bonding of zinc metal, just the zinc metal. You can say, so you can start like this. Zinc has a valence of 2, so it will be 2 plus, then electron, okay, which is negative. Then you also have, you can write zinc plus like this. Then you continue the process, the decolorization of electrons. Okay, this is the zinc ion. This one is what? Not decolorized, delocalized. Okay, delocalized electrons. Okay, so these are delocalized electrons. So you can have this delocalized electron, just negative, then zinc metal, all right, zinc ion, okay, or ion of zinc, then like this. Let me just end here. Zinc 2 plus, electron, zinc 2 plus. Okay, so you can just put the zinc ion in what? Alright, in circle like this. Okay, so we've just shown that this zinc, this is a zinc ion. Okay, then these are delocalized electrons. Okay, delocalized electrons. So therefore, this bond is not easily broken. It's not easily broken. It requires a lot of heat for this bond to break. Let's proceed. A learner carried out the following experiments. In experiment 1, 5 grams of powder of zinc, and in experiment 2, 5 grams of granules of zinc. Okay, that's these chops or pieces of zinc where each reacted with equal volumes of dilute hydrochloric acid, both of the same concentration, for 15 seconds. The reactions were not yet completed at 15 seconds. In which experiment was a large volume of hydrogen produced? Give a reason for your answer. This is simple. So the powder in experiment 1, okay, experiment what? Experiment 1. So experiment 1, okay, which is what? Zinc powder or powdered zinc. Powdered zinc. Listen, the reason it is very simple, okay. Powdered zinc, this experiment 1. So powdered zinc has a large surface area for chemical or just for the chemical reaction. Okay, for the chemical reaction. This is very simple. That's the reason. What would be the effect of reducing the temperature of the acid in the reaction? What is the effect of reducing the temperature of the acid in the reaction? So you know the temperature is one of the factors of rate of reaction that increases the rate of reaction. So if the higher the temperature, the higher the rate of what reaction. So when the temperature is reduced, automatically the reaction will be slower. Okay, the reaction will be slower or be reduced. Okay, will be reduced. That's what question is. What question is this? Question 7. Let's go to question 8. We are almost done. Just remaining with just in 2 questions. Just remaining with 2 questions. This and the last one, which is it organic chemistry? Yes, organic chemistry. Okay, so this is the question. The question reads, the following diagram shows the laboratory preparation of a gas and its collection. Now, listen and listen very carefully. Let's first study the diagram. There is dilute hydrochloric acid here, dilute hydrochloric acid, and a granules of metal or pieces of metal Y here, metal Y. Now listen very carefully. From here you can come up with something. You can know, you can predict the results. We've answered this question. What question was that? Let me just check. This question here, where an acid reacts with a metal. And when an acid reacts with a metal, hydrogen gas is produced and a salt. So, from here, you can even say, you can know that this gas is hydrogen gas. Okay? So, what's the first question? Identify one error in the setup, in the diagram shown. Okay? In the diagram shown. Now, look at this. Here, there has to be a tap. Here there has to be what? A tap on the funnel, okay, for opening and the closing or preventing the escape. As gas is escaping here, there's a reaction is taking place here. So there has to be a tap here to close the substance. So it's just one error. So you can just say the tap is missing. The tap is missing, okay, on the funnel. On the this funnel is the thistle funnel, okay, or thistle funnel, okay, which is above the reaction substance here, the reacting substances. So it's missing. Let's just proceed. Okay, proceed again. If you've noticed, there is also another reason here. This funnel is not dipped into the reacting substances here. It just ends here. Anyway, since we've already discovered one error, then we can proceed. Identify gas X. Gas X is hydrogen gas. Okay? Hydrogen gas. The formula for hydrogen gas is H2. it exists as a diatomic molecule. All right. Predict what will be observed if metal Y is replaced with copper. If metal Y is replaced with copper, you should also know that copper does not react with dilute acid. So, no reaction. Okay? There will be no reaction. Or we can just say there would be no bubbles formed. Okay, there will be no bubbles formed. Let me just write from here. Formed. Okay. Then this last question here, which is 2 marks. With reference to air pollution, compare the use of ethanol and diesel fuels. Okay, this is simple. Now, ethanol burns to produce less carbon dioxide. So, ethanol burns to produce less carbon. The two types of gases that are produced here. So there is carbon dioxide and carbon monoxide. Okay, while when diesel burns, it produces a lot of carbon dioxide and carbon monoxide. Okay, that's it. This question. Let's go to the last question. The last question. So the last question, B9, the question reads, the following table shows some of the fractions of hydrocarbons obtained from fractional distillation of crude oil. All right? Of crude oil. Nice. So fraction A, B, up to C, up to D, then these are the boiling points ranges. So this one has the lowest boiling point, the lowest range of boiling point. This one has the highest. So expect this one to have the highest chain of hydrocarbons or carbon chain. What's the first question? Which fraction contains the longest chain? Oh, give a reason for your answer. Nice. So you can just say fraction D. Fraction D. Okay? The reason is very simple. Because it has the highest range of boiling point. Highest range of boiling what? Boiling point. because it has the highest range of boiling point, 200 to 360. Okay. Next question is question what question is this? Question B. Decane 1022 can be cracked to produce hexane C6H1214 and one other hydrocarbon T. Nice. Nice. This is okay. This is good. Now, listen. And listen very, very carefully. Cracking results in the formation of an alkane and the alkene, a saturated and then saturated hydrocarbons. So since this one is an alkane, hexane, then what is remaining is an alkene. Now, how can you know that this is what is remaining? Just subtract. Look at this. Let me show you here. C10H22. From here, you come up with what? When you come up, this one is cracked to form C6H14. So you ask yourself, how many carbon atoms are remaining? You are remaining out of 10. You subtract 6, remaining with what? 4. Then how many hydrogen? 20 minus 14. 20 minus 14 is what? Is it 20 or 22? This is 22. Okay. 22 minus 14 is 8. So the formula for T here is C4H8. C4H8. That's how you calculate. Okay, C4H8. Just subtract, since it's cracking, just subtract what you are given there. If you want to come up with this, just add these two, you come up with what? Decane. Well, what is the name of this substance? This is butene. This is butene. This is butene. This is an alkene. Now we are asked to draw the displayed structure formula of T. Okay, no problem. We're going to say the first carbon to carbon will be a double bond, since this is an alkene. Then you have, since we have three what? Carbon atoms, so 4 carbon atoms, so it will be C double bond to C, then C to C, then single bond is single bond. Okay, so here we're going to have this like this, the displayed structure. Hydrogen atoms there, like this. So since here this is a single bond, we have hydrogen here. You don't have add hydrogen here because there's a double bond here. You need to break this double bond for you to add another for this to react with other elements. Okay, so this is what have I done? What have I done? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, I've made a mistake. So remove this hydrogen. This is a common mistake that is usually made. Okay, since we have an hydrogen here closing, so you don't even have to have hydrogen here. So this is the displayed structure. Okay. All right. Let's proceed to the last question of section B. The last question of section B is saying, would you expect hydrocarbon T to undergo polymerization? Explain your answer. Yes. Yes. Absolutely. Okay. Absolutely. element T, is it hydrocarbon T can undergo polymerization because it contains the double bond, a double carbon to carbon covalent bond, double bond. Okay, double bond. Look at this. This is question 9. Then section C, question 1. So section C, you have 3 questions, and you have to answer 2 questions. So these are the questions in section C. Now, this is the last question here. So you will answer section C in a different video. I'll make a different video for section C only. So guys, if you are still together up to this point, consider subscribing to the channel and liking the video. Thank you so much. Okay.